Welcome to e-learning. My name is Abdrashid Makwata, a teacher of mathematics and chemistry. Today, we are going to look at statistics 2, a Form 4 topic. So generally, statistics is taught in two classes, that is in Form 2 and Form 4, and it can both be set in Paper 1 and Paper 2. So in Form 2, you looked at the introduction to statistics. You looked at what statistics is, then methods of collecting data, methods of presenting data, then you looked at measures of central tendency, measures of central tendency. So on data presentation, you looked at different ways in which data can be presented. That is by use of pictorials, frequency distribution tables, bar graphs, line graphs, histogram, frequency, polygon, pie chart, and line graphs. So hope you know how to use each one of them. Then you also looked at measures of central tendency. That is the mean, the mode, and the median. And when we are looking at this, you looked at both grouped and ungrouped data. There are two types of data, grouped and ungrouped. So we looked at how you can calculate median of both grouped and ungrouped data, and how can calculate also the mean of both grouped and ungrouped data. But now in this Form 4 topic, we are just continuing with what you learned in Form 2. So we start by looking at mean. And before we go to that, let's look at what are the objectives of this Form 4 topic. What are the objectives of this Form 4 topic? So by the end of this Form 4 topic, the learner should be able to calculate mean using the assumed mean. So that's the first thing we learned. How can we calculate the mean now using the assumed mean? Then number 2, how can we calculate the quartile, the decile, and the percentiles? You remember in Form 2, you looked at how we can calculate median. So we are extending here to calculate the quartile, the decile, and the percentile. And after we have calculated the quartiles, we shall look at the upper quartile and the lower quartile. Then we can calculate now the what we call the semi-interquartile range, the semi-interquartile range and the interquartile range of this data. Then the other thing, we learn how you should be able to draw a frequency distribution table. A frequency distribution table, it's also called an ogive curve. Then you use that ogive curve to get the median, the lower quartile, the upper quartile, the percentile, and the deciles. Then from there we shall also look at the measures of dispersion, where we will calculate the mean absolute deviation, the variance, and the standard deviation, also called the square mean deviation. So let's start with the first one, the calculating mean using the assumed mean. Calculating mean using the assumed mean. So when we are calculating the mean using the assumed mean, we use the formula above, that is assumed mean plus summation of FD over summation of F over this one is supposed to be summation of F, summation of F. So we know in Form 2 we calculated mean, the normal way of calculating mean, just using summation of f of x over summation of f of both grouped data and ungrouped data, but we know when we are given ungrouped data, just the numbers there with no frequency, we just add all the numbers, all the values, then divide with the number of those values. That one, we are just getting the average of those. Then if you are given data with what, with frequency, you will multiply that quantity, that is what you call x, multiplied by frequency, then we add. So we add to get summation of f of x, then we divide by the total frequency, because summation of f. Then if you have been given grouped data, we will find the midpoints, what we call x, the x value, get the midpoints, that is the upper class plus the upper class limit plus the lower class limit divided by, or just the upper value plus the lower value divided by 2, you get the midpoints. So multiply the midpoints by the frequency to get f of x, then you get the summation of frequency. So that you get the mean by taking summation of f of x over summation of f over summation of f. So this one, we are going to do it differently. We are going to use the assumed mean. So how can we use the assumed mean to get the mean of a certain value? So let's look at just here, calculating mean using the assumed mean. So use the formula A stands for assumed mean plus summation of FD over summation of F. So F, you know, is frequency. That symbol stands for summation. F stands for frequency, and D stands for deviation. So let's look at what is this. What is this that we are calling deviation? We call it the deviation from the assumed mean. So if you have been given data, you start by guessing just a value. We just say that maybe the mean of these values is this one. That value is what we call the assumed mean. So you look for your own mean by not calculating, but just guessing. So any mean tunaita the assumed mean. So you look for the assumed mean, then you get the deviations now from x. So kumbuka, you have been given now the values. You have the values of x. Now you'll be getting these deviations from the assumed mean by taking x minus assumed mean. So one, you should know how to get this deviation. So on the deviation, what we get the deviation by taking x, the value of x minus the assumed mean, Maybe let's look for an example of a question. How we can calculate the mean of values using the assumed mean. Like we have an example one, a question here. You are told use the assumed mean method to calculate the mean of the following numbers. You have been given the numbers 67, 68, 69, 71, 73, 74, 75, 79, 80, 83, and 85. Then you are told to get the mean using the assumed mean. You have not been given the assumed mean, so you are supposed to just guess the mean from these values. So you can just say, so looking at the values, the least value is 67 and the highest is 85. So for me, I chose my assumed mean to be 72. So 72 is my assumed mean. So then I created a column, that is a column of X to represent the values, then a column of the deviations from mean, so such that now if I have 67 is my first value, so I take 67 minus 72 to get -5. So -5 is my first deviation. Then the second one is 68 minus 72 to get -4. So -4 is my another deviation. Then for 69, the deviation is -3. 71, the deviation is -1. 73 minus 72, I get 1. 75 minus 72 is 3. 79 minus 72 is 7. 80 minus 72 is 8. Then 83 minus 72 is 11. 85 minus 72 is 13. Now I have a column of the deviations. So I know to get the mean, I have to get the summation of FD. So I have to multiply the frequency with the deviations. But here in our data, there is no frequency, or we know the frequency we know is the number of times a value occurs. So 67 only occurs once, so meaning it has a frequency of 1. So all my values have a frequency of 1. So I can say I don't have a frequency, so no need of multiplying the deviations with the frequency. That's when we are given data with no frequency. So there's no need of getting the FD. So just use D. So I get the summation of D, that is -5 plus -4 plus -3 plus -1 plus 1 plus 3 plus 7 plus 8 plus 11 plus 13. So that total it gives a total of 30. So summation of FD is 30. Then I look at summation of F, the summation of frequency, or how many values are there, how many quantities are there. So I can just count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 values. So I divide 30 divided by 10, that is summation of FD over summation of F, to get 3. So if I get 3 is my summation of FD over summation of F. So I add that one to my assumed mean. So 72 plus 3, and my mean will be 75. My mean will be 75. So you can use the normal method. You can confirm with the normal method. Add all those numbers, then divide by 10. We'll get the same value, 75. That is group data. Let's look at example 2. Example 2. So we have example 2 is here. Example 2 is here. You are asked that a student of Form 4 class were weighed, and their masses were recorded as follows. Using the assumed mean of 54. Calculate the mean mass. So here you have been given the assumed mean. So this something you should make note of, that if you are calculating mean using the assumed mean, the examiner can give you the assumed mean, or the examiner may not give you the assumed mean. So in case you have been given the assumed mean, don't choose your own assumed mean. Please use the one given. But if you have not been given, you choose the assumed mean of your own, any value. We know in a class everybody can choose his or her own assumed mean, but after calculating they will get the same answer. So here you have been given the assumed mean of 54 and we are told to calculate the min mark. And when you look at this data, is slightly different from the one you have done in example 1. In this data, you have been given values with frequency. So what this data means, it means 48 appears one time. So that's why you are saying 48 has a frequency of 1. 49 appears 49 times. So meaning 49 has that's why 49 has a frequency of 3 and so on. So when you look at 54, 54 appears 7 times and that's why it has a frequency of 54. Then 55 appears 6 times. So frequency is the number of times the value appears. The number of times the value appears. So you have frequency, then you have the masses in kg. That is x, what we call x. Now from there we know the procedure. We say that 1, you have to get the deviations from the assumed mean, the deviations of x from the assumed mean. And you get the deviations of x from assumed mean by subtracting the assumed mean from x. So itakuwa inakuwa x minus assumed mean. So our assumed mean is 54. Here you have the first value is 48. So it's 48 minus 54. You will get negative 6. Then 49 minus 54, you get negative 5. 51 minus 54, you get negative 3. 52 minus 54, you get negative 2. 54 minus 54, you get 0. 55 minus 54, you get 1. 57 minus 54, you get 3. 58 minus 54, you get 4. 59 minus 55, you get minus 54, you get 5. Then 60 minus 54, you get what? 7. You get 7. So correct that one. You get here is 7. 7. Then we have frequencies. So here you have been given frequencies. You have frequency of 1, 2 up to 2. So if you have been given the frequency, you have to multiply the what? You have to multiply the deviation by f to get FD, because in the formula we have summation of FD over summation of f. So get the FD by multiplying the deviations multiplied by frequency. So here I have an FD column, that is I'm multiplying D minus f, that is 6 multiplied by 1, 5, negative 6 multiplied by 1, negative 5 multiplied by 2, with that column up to the last one. So from there I have to get the summation of FD. Summation of FD means the addition of FD. When I add the values of FD, I am getting 17 there. Then I have summation of F to be 40. Summation of F to be 40. So to get my mean, I use the formula assumed mean plus summation of FD over summation of F over summation of F. So my summation of FD is 17 and summation of F is 40. So 17 divided by 40 is 0.425. 0.425. Then I had my assumed mean as 54. So 54 plus 0.425, I get 54.425 as my mean. So remember, 54.425 is my accurate mean. So an assignment, use the assumed mean of 50. Use the assumed mean of 50 to do this question. The same question. So try that one. Try to use the different assumed mean. So here I have used mine 54. I'm giving you an assumed mean of 50. Use an assumed mean of 50 to get the mean of the mean mass of these students. So you will see if you will get 54.425. Okay, so that one you will do it at your own time. So let's look at another example. Example 3. Example 3. Example 3. Example 3. So you have a question here that telling you that the heights of number of trees seedlings were measured and recorded as shown below. So you have a column there, the height in centimeters, then frequency f. From okay, so look at this data, then compare with the other data that we have dealt with. This one now, the data is given in classes. This type of data is what you call grouped data. Is what you call grouped data. So what we mean here, this data has been given. This data has been given in groups. In groups. So it means there are so many. They were taking data of so many seedlings. So they can write the every height of each seedling here because there are so many. So what they do, they group them. So they say those seedlings that had a mass from 10 to 14, they were 5. So they group them like that. The one that they had a height of 10 to 14 centimeters. Those seedlings that had a height of 15 to 19 centimeters, they were 11. Those seedlings that had a height of 20 to 24 centimeters, they were 40. I mean, they were 18. Then those seedlings that had a height of 25 to 29 centimeters, they were 40. Those seedlings that had a height of from 30 to 34, they were 20. Then from 35 to 39, they were 6. So that's what that data means. So if we are dealing with this type of data, remember you don't have x. You don't have one value. Nakumbuka on the formula you have to get the x, then get the deviation by taking x minus the assumed mean, then get the what? I mean the accurate mean now. So, but here you don't have x, and the question is, calculate the mean height. Calculate the mean height using the assumed mean. So, just like the first example one here, you have not been given the assumed mean, so you have to take the assumed mean of your own. You take the assumed mean of your own. Unachagua tu yeyote yenye wewe unafikiria inaweza kuwa nini. Like, but try to use some reasonable mean, so that you don't work with so that you don't work with large values. Like here, the centimeters, we know the smallest seedling has a height of 10 centimeters and the highest at 9 centimeters. So you can just average from there. Maybe from the average can be the 30 or 20 something, 28, 29, 30, somewhere there, 35 or ukunyum. So choose an average value somewhere there so that you work with small values. So I have I have my assumed mean. So I chose my assumed mean to be 29. So my assumed mean is 29. So I have to make a table with those ones, the classes. Then since I don't have the value of x, I have to make a column of x. X is now the midpoint of the class. the lower value plus the lower value divided by 2. Let's look at how we get x. Like the first class is from 10 to 14. So I take 10 plus 14 is 24. 24 divided by 2, 12. So 12 is my first x there. Then in the second class is 15 and 19. 15 plus 19, it's 34. Then 34 divided by 2, I get 17. So 17 is my what? My another x. Then 20 plus 24 is 44. 44 divided by 2 is 22. 22 is my value of x there, my midpoint. Then 30 plus 34, not really. 30 plus 34, I will get 64. 64 divided by 2, it's 32. So I get 32 as my value of x. Then 35 plus 39, we get 60 what? You get 74. 74 divided by 2, you get 37. You get 37. So 37 is my midpoint. But you can look at the midpoint, the values, they have a similar character. Look at the first value is 12, 17, 22, 27, 32, 37. So if that data was continuing, the next value will have been 42, then 47, 52, 57, 62, 57. So look at that. So you can just get the midpoint direct as simple as that. Then after you have now the midpoint, the value of x, you get the deviations from x. The deviations from x. You have the assumed mean. Mine is 29. So then you get the deviations. The deviation of x. The deviations of 29 from x. Now we are taking x minus the assumed mean. Please don't confuse to take assumed mean minus x. We are taking x minus assumed mean. So we start with x. So not looking at the difference, but nandana x minus your assumed mean, because there are deviations from x. So my first deviation from x is negative 17, taking 12 minus 29, apart negative 17. Another one, that is the second one is negative 12. That is 17 minus 29. 22 minus 29, I get negative 7. 27 minus 2, I get negative. 27 minus 29, I get negative 2. 32 minus 29, I get 3. Then 37 minus 8, I get 8. So that okay, those are my deviations. Since I have a frequency on my column, I will be multiplying I'll be multiplying frequency multiplied by deviations. Frequency multiplied by deviations. That is 17. So to get FD, I'm multiplying the frequency deviation. 17 times 5, 12 times 11 to get 132. 7 times 18 to get 126. 2 times 40 to get negative 40. 3 times 20 to get 60. 8 times 6 to get 48. So I have to get the summation of FD, then summation of my frequency. So summation of my frequency is 100. So there are 100 seedlings. Then my summation of FD, the addition of all these one is negative 315. So look at it. I have a negative value. So if I have a negative value, what it means, my assumed mean was larger than the accurate mean. So negative 315 divided by 100, I get negative 3.15. 5 as my summation of FD over summation of F. So when I take 29 plus negative 3.15, I get 25.85 as my accurate means. That is 25.85. 25.85. So that's the last example on how to get the mean using the assumed mean. How to calculate the mean using the assumed mean. So in the next class, we shall look at how to calculate the quartiles, the percentiles, and the deciles. The quartiles, percentiles, and the quartiles.